The Award of Merit for 2004 in the category of materials goes to Umicore of Belgium for their work in developing and introducing a novel and innovative alloyed metal powder named Cobalite CNF. This material has been designed as a cobalt and nickel-free replacement for cobalt powders and for cobalt-containing pre-alloyed powders commonly used in diamond tool manufacture. Various qualities of cobalt powder are used in diamond tool manufacture, typically with primary particle sizes between 1 and 5 microns Fisher size. Over the recent years, pre-alloyed powders with a lower cobalt content in the same size range have also been successfully marketed for this purpose. Such powders are, however, relatively simple pre-alloyed powders, consisting of a pure copper phase and an iron phase hardened by a solid solution hardening with cobalt. There are major commercial disadvantages in the use of cobalt powder in terms of the high price and price volatility of cobalt. Any replacement product should therefore aim to be significantly cheaper. Additionally, the replacement product should contain only elements that are less hazardous to human health. Therefore, the metallurgy of cobalt CNF needed to be more sophisticated and was developed only after an extensive research program. In existing pre-alloyed powders, a copper phase and a solid solution hardened cobalt iron phase are used. By way of contrast, in Cobalite CNF, tungsten is used instead of cobalt to provide solid solution hardening in the iron phase. Additionally, tin is used as a solid solution strengthener of the copper phase in order to increase its hardness. Finally, yttrium oxide is used to provide oxide dispersion strengthening to the entire matrix. Rapid cooling after sintering, faster than 100 degrees Celsius per minute, is customary in the diamond tool industry. This led to material embrittlement and posed a major challenge during the development process. This embrittlement arose firstly as a result of diffusion of tin into the iron phase during sintering, and secondly by the formation of very brittle tin iron intermetallics during the rapid cooling. Umicore found that the tungsten present in the iron phase reduced the diffusion of the tin and thus prevented embrittlement. The Cobalite CNF product consists of pre-alloyed particles of around 2 micron diameter, agglomerated into porous granules of around 10 micron diameter. Cold compaction at normal pressures gives green compacts of adequate handleability, better in fact than the reference cobalt powders normally used in this application. These are the properties of the material. Using a wet chemical process followed by reduction, Umicore have produced a cobalt and nickel-free alloyed powder with primary particle size of a few microns that approaches the properties of cobalt powders. This unique powder, which has patents pending, offers a number of advantages to the diamond tool producer. Cost savings of 25 to 50% compared to cobalt powder. A product that consists entirely of elements which are less dangerous to human health than cobalt. Lower sintering temperatures are possible than with alternative materials. Thanks to the work of the team at Umicore, this new material offers substantial benefits to PM producers and thus justifies the EPMA Award of Merit for 2004 in the category of materials.